Hello, discrete math fans. Let's give a few definitions. We're going to say that sets A and B are disjoint, provided that A intersect B is empty. That is to say, there's no overlap between the two sets. Then we're also going to say that a collection of sets, A1 through AN, this could be a finite collection, it could be an infinite collection. This collection of sets is called mutually disjoint, or sometimes it's called pairwise disjoint, if AI intersect AJ is empty whenever I is not equal to J. And finally, this is what we're leading up to, a collection of non-empty sets, A1 through AN, and again, this could be a finite collection or it could go on forever. This is called a partition of A if the following two things are satisfied. First of all, if we take the union of all the AJs, now notice I'm not putting a limits on this union because it could be a finite union, it could be an infinite union. If that union is equal to A, and if the collection of sets is mutually disjoint. And don't forget about being non-empty. Each one of these sets has to be non-empty. So let's give an example of a partition. We'll define the sets A0, A1, and A2 as follows. So here are the sets A0, A1, and A2. You should be able to see what's going on with these sets. Here's another way of defining the sets. A0 is the set of all integers for which n is equal to 3q plus 0 for some q in the integers. You don't have to write the plus 0, but it fits in nicely with the rest of them because A1 is the set of all integers n such that n is equal to 3q plus 1 for some q in the integers. And then the same kind of definition for A2. So here's the question that we really want to ask. Is the collection A0, A1, A2, is that a partition of the integers? And the question that we need to answer is this. Given any n in the integers, is n in exactly one of A0, A1, and A2? So every n has to be represented in one of these sets, but one and only one. And the answer is yes. And how do we know this? So it's the quotient remainder theorem that tells us these sets are mutually disjoint and exhaustive. Mutually disjoint, of course, there's no overlap because you can't have an integer with two different remainders when you divide by 3. And it's exhaustive. Every integer is represented in one of these sets. Okay, that's all for now.